Hello everyone. In this video, let's discuss how to write the program for design front, middle, back queue. Design a queue that supports push and pop operations in front, middle and back. Implement the front, middle, back class. So front, middle, back initializes the queue. So this is a constructor, we have to initialize the queue. Void push front, I have to add the element in the beginning. Void push middle, I have to insert the element in the middle. Void pushBack, I have to insert the element at the back. popFront, I have to remove the element from the front. popMiddle, I have to remove the element in the middle. popBack, I have to remove the element in the back. If it is not possible, if the queue is empty, I have to return -1. Then there is one more note they have given. Notice that when there are two middle position choices, the operation is performed on the frontmost middle position choice. For example, pushing 6 into the middle of 1, 2, 3, 4, 5. So here we have odd number of elements. So 5 divided by 2 is 2. On the index value 2, I have to insert the element called 6. So 1, 2 and 6, 3, 4. So on the index value 2, I have inserted. Now what if we have even number of elements? There only we have to check very carefully. Popping the middle from the queue. So when I take 6 elements, 3 and 4 both are middle elements. So here first preference should be given to the frontmost. So 3 should be removed. So the output is 1, 2, 4, 5, 6. Okay, let's go for the program. Example 1. Front, middle, back queue. So I have to initialize the queue. First let me declare the queue. So list, I'm going to serve only integer value. So I'll take integer. The name I'll give it as ARR. Now I have to initialize ARR equal to new array list. Done. Next, push front. So when I want to insert the element in the beginning, okay, I have to take the queue name ARR, okay, ARR dot add. So add method helps to insert the element inside my queue. Here I have to mention the index value because I am going to insert in the beginning front. So on the index value 0, because whenever we are starting, the index value starts from 0. On the index value 0, I have to insert what value. So that value I have passed as an argument here, VAL. On the index value 0, I have to insert VAL. That's all. Next is push front over. Next is push back. So I'll go here. I have to take ARR dot add. Just you can give val. Whenever we are using the method called add, automatically it inserts the element at the last only. So you don't want to mention the index value. Directly you can add. Next, push middle. I need to insert in the middle. So for that I have to get the index value first. So I'll get int index is equal to take the size of the array ARR dot size. I'll take the size and that should be divided by 2. Okay, fine. Now what I'll do, ARR dot add. So index value, comma what value I'm going to insert. Done. So I'm done with push front, push back and push middle also. Now I have to go for pop front. So I want to delete in the beginning. So if you want to delete, I have to use the method called remove. So for that first I have to check whether it's empty or not empty. So I'll give a condition if ARR dot is empty. If the queue is empty, I cannot delete the element. So directly I'll return -1. If the queue is not empty, okay, I have to take the value. That value has to be returned. So here, if I'm popping front element, what element I'm popping, that has to be returned. For that I'll take the value first. So I'll take int result is equal to ARR dot. I'm deleting element from the beginning. So beginning means index value is 0. So get, if you want to fetch that particular element, here we cannot use index values because it's array list. So I have to use a method called get. So ARR dot get of 0. I'll get the front element. Now ARR dot remove the index value 0. So remove method helps to remove the element from the list. So which index value? So 0th index value, not the element 0. On the index value 0, I have to remove. Now I have to return the value. So the value I have stored in a variable called result. So return result. Done. Pop front over. Next, pop middle. Okay. So when we go for middle, we have to be very careful. First I have to check whether it's empty or not. Say ARR dot is empty. If it is empty, I have to return -1. Okay. Else, what I have to do? First, I have to find the ID, index, int index. What if we have even number of elements? So we have to check that also, right? For that, I have to check a condition that whether the size of the array is even, if it is divisible by 2. If it is even, I have to take the size divided by 2 minus 1, because here we have mentioned, right, if we have 6 elements, 6 divided by 2 is 3, but I have to delete the index value 2. That's why 6 divided by 2 is 3, 3 minus 1 on the index value 2, whatever I have, that should be deleted. If I have odd number of elements, directly I can give arrow dot size divided by 2. That's all. So I'll get the index value first. After getting the index value, I have to remove arrow dot remove index. Done. So index value I've got, I have removed. So before removing, I have to take that value, right? So how can I take the value? In result is equal to arrow dot get of index. So the element which I'm going to delete, that I'll be taking, and I'll be deleting this. So after deleting, I have to return the variable called result. Done. Next, popBack. So I have to delete the last. So first I have to check whether it's empty or not. Arrow dot is empty. If it is empty, I'll return -1. If it is not empty, what should I do? First I have to get the value. So int result is equal to arrow dot get of arrow dot size -1. Why we are giving -1? Total element size -1, because index value starts from 0. So I have got the value. After getting the value, I have to remove arrow dot remove arrow dot size -1. Last element has to be removed. Then I have to return the result, because which element I am going to remove, that has to be returned. That's all. So we have done with all the methods. Let's run the code now. Let's pass the test cases. Let's submit the code. Let's pass all the test cases. That's all.